Hello everyone, my name is Bakotia and I'm Assistant Professor in Mechanical Engineering, Rai School of Engineering, Rai University. Today we are going to talk about our topic kinematics. So let's start. Now if you see that kinematics is a part of theory of machines. Now the first question that will arise in your mind is why study theory of machines? The reason is that theory of machines is studied to understand the relative motion between the two parts of the machines. I'll explain you further what exactly is the relative motion between the two parts of the machine, and it is also to study the forces acting on the various parts of machines. Moving further, you can see that the theory of machines is further classified into two main branches. The main branches are kinematics and dynamics. Out of that, we are just going to focus on kinematics. Kinematics, the word itself tells you kine means motion. So we are going to study everything regarding the motion of the machine parts in kinematics, while in dynamics we are going to study about the forces. Moving further, you can see that relative motion between the parts of machine is kinematics, and the forces which are going to act on various parts of machines is known as dynamics. So we are going to keep our focus thoroughly on kinematics. Moving further, you can see that kinematics is motion study. So like I told you, kinematics. So kine means motion. So that's why if a part has started moving, what kind of motion it will have, whether it will have circulatory motion, whether it will have sliding motion, linear motion, and what motion it is going to transfer further, that is we are going to study. We are also going to study that if a part is moving, then what will be its position, what will be its displacement, what will be its velocity, acceleration. All those calculations fall under the category of kinematics. In short, if I'm going to give the dimensions as the input, then the output can be found out as position, displacement, velocity and acceleration of any single element of the machine. Moving further, you can see that if I want to study machine, I'll have to first break it into parts. So the single part of a machine is either called as link or element. So it is any body normally rigid which has motion relative to another body, that we are going to call it as link. For example, you can see that links can be divided into three categories. The first is binary link, the second is ternary link, and third is quaternary link. So you can see here, this is the binary link, this is the ternary link, and this is the quaternary link. If I want to further explain you what the link is, then we can understand from this diagram of reciprocating steam engine. You all know how a reciprocating steam engine functions. You can see here, this is first part, which is crank. When the crank will rotate, the connecting rod is going to oscillate. Just like a pendulum, the connecting rod will start oscillating. When the connecting rod will oscillate, the piston is going to reciprocate inside the cylinder. So I can call crank as link, the connecting rod as third link, the piston as the fourth link, and our fixed cylinder as one of the links. So there are total 4 links: crank, connecting rod, piston and cylinder. If I want to further explain you, let us see the animation of this reciprocating steam engine. You can see here, the crank is rotating. When the crank will rotate, then and then the connecting rod will start oscillating. And once the connecting rod will oscillate, the piston will slide inside the cylinder. So I can call crank as link 1, the connecting rod as link 2, piston as link 3, and the cylinder as link 4. So link is nothing but any body which has relative motion with respect to another body. So connecting rod will have relative motion with respect to crank. It means if the crank will not rotate, the connecting rod will not oscillate. This is the meaning of link. Let us move further and see the another terminology which is called as the link and element. Now in this, I'll tell you further that the 3 types of links are there: quaternary link, ternary link, binary link. Whichever link that we saw in the previous animation was this binary link. all the links which we saw in reciprocating steam engine, like crank, connecting rod, piston, these all were binary links, but it is not mandatory. You can use the ternary link or quaternary link as and when required to fulfill the motion and complete the mechanism. Moving further, we know now what the kinematic link is. Let us see what a kinematic pair is. So, when two links are connected in such a way that links have constrained motion, fixed motion, and the pair of links is called as kinematic pair. For example, you can see here there is a rectangular bar which is sliding inside the rectangular slot. So this rectangular bar and rectangular slot are two links which form one pair. So when two links are connected with each other and they have only one definite motion, they are called as kinematic pair. You can see here, this will the another diagram of 4-bar mechanism. Now in a 4-bar mechanism, you can see the crank and connecting rod is one kinematic pair. The connecting rod and this rocker or lever is one kinematic pair, right? So how the motion is transformed? When the crank is rotating, connecting rod is oscillating, and the rocker or lever is also oscillating. So this is one pair, this is another pair, this is third pair. So different links, when they connect with each other, it is called as kinematic pair. Moving further, let us move to what the constrained motion is. Constrained motion means the restricted motion or motion in only one definite direction. Motion in only one definite direction. It should not be in two directions, because if it is more than one direction, then the assembly will not get fulfilled. So we can say that there should be restricted motion. If there is a restricted motion, then we can say it is a constrained motion. One element has to have only motion in only one definite direction. If the motion is in more than one direction, then we cannot call it as a constrained motion. Let us understand it further. There are three types of the constrained motion. The first type is completely constrained motion. The word itself tells you completely constrained, means that it has only one definite direction. So you can see when the relative motion between the pair of links is only in one definite direction. Let me show you with the example. You can see here this rectangular bar in the rectangular slot can only slide. It has only one definite direction. It cannot rotate, right? Same way, there is a shaft which is inside the bearing, and I have fixed here with the keyways of the shaft. So the shaft can only rotate. It cannot move or slide. So when there is only one definite direction, then that motion is called as completely constrained motion. Moving further to the second type of motion, which is called as successfully constrained motion. Now what is successfully constrained motion? When the relative motion between the pair of links is not completely constrained, but we are making it by some other means we are going to do something that it was not a completely constrained motion, but we are turning it into a completely constrained motion. That is called as successfully constrained motion. Let us see with an example of the footstep bearing. What is a footstep bearing? You can see here there is a shaft, and at the foot of the shaft the bearing is placed. That's why it is called as footstep bearing. Now normally this shaft could rotate and it could move up and down, but what I have done, I have placed one force over here. So now I have applied some means so that only one direction can take place. Previously 2 directions could have taken place which were there. It could rotate as well as it could slide. But if I am going to apply a load over here, now the shaft will not be able to slide. It will only be able to rotate. So it will have only one definite direction. So I will call it as successfully constrained motion. Moving further, the third type of motion is incompletely constrained motion. Now when the two links are connected in such a way that the relative motion between them is in more than one direction, right? Let us see with an example. You can see here the shaft which is there inside the bearing. Now it has two directions of motion. Which are they? It is having a circular motion as well as it is going to slide. So this is not a completely constrained motion because it has motion in more than one direction. You can see here it is having motion in more than two directions. So to complete a mechanism, every part should have completely constrained motion, otherwise the assembly will not be fulfilled and it will not function properly. Moving further, let us see the another terminology which is regarding the types of kinematic pairs. I told you already that when two links are connected in such a way, then they'll be called as the kinematic pair. Let us do a broad classification of kinematic pair. According to nature of contact, there are two types. According to type of relative motion, there are 5 types, and according to type of closure, there are again 2 types. You can see that the broad classification of kinematic pairs is done. First one is lower pair, the second is higher pair, there is sliding pair, turning pair, rolling pair, screw pair, spherical pair, self-closed pair and forced closed pair. We are going to do this classification in very much brief, so you will understand each term very nicely. Let us start with the first one. Based on nature of contact between the elements and the type of pair is lower pair. Now you can see in the diagram itself that when the two links, you can see this is link number 1 which is shaft, this is link number 2 which is bearing. You can see here there is a surface contact. There is a surface contact between the two bodies. Same way you can see here there is a rectangular bar inside the rectangular slot. There is a surface contact between the two bodies. So when two links are connected in such a way that if there is a surface contact between the two bodies, that type of pair is called as lower pair. Moving further, let us see what is a higher pair. Now, higher pair means when the two bodies or two links are connected in such a way that they have a point or a line contact, right? Now, you can see here, this animation shows you a wheel or an axle of a railway bogie. How the railway bogie moves. When the axle is fixed, it is also fixed with the help of a bearing. Which bearing? The rolling contact bearing. Now you can see here the contact between the rolling contact bearings is a point contact, right? And here you can see it is a line contact. So surface contact is not there, just a point or a line contact between the two bodies is done, then that type of pair is called as a higher pair. So the difference between lower pair and higher pair is that if the two bodies are moving and if they are having a surface or area contact, you will be calling it as a lower pair. But if they are having a point or a line contact, you will be calling it as a higher pair. Moving further, based on the relative motion, the first pair is the sliding pair, right? What is sliding pair? When the two bodies are connected in such a way that one link slides inside the another link. You can see here the piston is sliding inside the cylinder. So this pair will be called it as a sliding pair. Moving to the second one, the turning pair, or it is also called as revolute pair. What is the definition? The definition of turning pair or revolute pair is that when two links are connected in such a way that one body turns with respect to another body, right? Here what is going to happen? The shaft is going to turn with respect to bearing. That's why this will be called as a turning pair. Let us move to the third type of pair, which is a cylindrical pair. You can see here the cylindrical shaft is rotating inside the bearing, or you can say a circular hole. So when one link is connected to another link in such a way that a cylindrical pair of links is formed, then we will call it as a cylindrical pair. Let us move to the fourth one, which is a rolling pair. When one link, you can see this is a belt drive which is moving onto the pulleys. So when one link is going to roll over the another link, like here the belt is rolling over the pulleys, then that type of pair is called as a rolling pair. Let's move to our fifth type of pair, which is called as the spherical pair. What is a spherical pair? One more figure will make you clear exactly what the spherical pair is. Guys, you would be seeing a joystick in a video game, or even in your cars you would be rotating your clutch body or the gear body. Then this is similarly like that, when the two bodies are connected in such a way that one body which is of a spherical shape, you can see this is a sphere, when one body of a spherical shape moves inside the another body which is fixed, then that type of pair is called as spherical pair. The animation of this spherical pair is seen. You can see here the body not only moves in the vertical direction, horizontal direction, but it can slide into 360-degree rotation. So that type of pair is called as the spherical pair. The best example of this is the ball and the socket joint. Moving further to another type of pair, which is a helical pair or a screw pair. Now the best example of this is nothing but a screw and a nut. How to define it? You can say that when one body moves inside another body, both having the threads cut inside them, then that pair is called as spherical pair. How? You can see here the threads are external threads inside on the shaft, and the nut is going to have the internal threads. So when the two bodies are connected in such a way that they have a thread pair, then that type of pair is called as a helical pair or a screw pair. Let us move to the third type, the C type of classification based on the nature of the mechanical constraint. In the first one, there is a closed pair. I can also call it as a self-closed pair. Now see here, the rectangular bar moving inside the rectangular slot, there is no extra element that I require. They are self-closed. They are closed by themselves. I don't need to do any extra arrangement for their motion. They will move on their own. But in the second one, you can see the classification number B which is there. Then in that, there is an unclosed pair or forced closed pair. What is unclosed pair or forced closed pair? You can see there is a cam. When the cam will rotate, the follower will move up. But sometime what will happen? The follower might get stuck over here. It won't come down. Then I have placed one extra element which is spring. What will spring do? It is going to bring the follower back to its original position. So this type of pair is unclosed pair, and by putting a spring force, I am turning into a forced closed pair. So the simple difference between both of them is, here I don't need any extra arrangement, but here I need some extra arrangement so that the two links become a pair and that pair becomes a forced closed pair. Next, let us move to the kinematic chain. Now, we started with link, the next term was pair, and now there is a chain. So a kinematic chain is nothing but a combination of pairs. When two links were connected, it formed pair, and when two pairs are connected, it will form a kinematic chain. So kinematic chain is nothing but each link will be a part of kinematic pair, and there will be some relative motion, and more precisely, always it should be a completely constrained motion, otherwise it will not function like a kinematic chain. To give you more example of this, let us move further. You can see here, this is again an example of a kinematic chain. You can see link 1, 2, 3 and 4. So two pairs, these are the two pairs and these are the two pairs. When two pairs combine with each other and when they have a completely constrained motion, then this type of example is called as a kinematic chain. You can see a full chain is there and it is rotating. Right? So it means it has completely constrained motion in it. It does not have incompletely constrained motion. Let us move to another terminology which is called as mechanism. Now you can see that what is mechanism? A motion transforming device. The best example of a motion transforming device for a mechanical engineer could be a drafter. You know, when you use a drafter on your board to draw your drawing sheets, the only motion is transformed from one place to another on your desk. So that is an example of a mechanism. Also, when one link of kinematic chain is fixed, you could see there in the previous example that one link was a fixed link which was frame. So unless and until there is no fixed link in a chain, it won't be called as mechanism. But once you decide that there is a fixed link in the kinematic chain, it becomes a mechanism. Let us move further. You can see that any mechanism is not called mechanism unless and until the fixed chain or the fixed link frame is not decided. Let me explain you more in detail in the next figure, right? You can see here that both the mechanisms previously which I had explained you are there. The first is the single slider crank chain mechanism and the second one is the 4-bar mechanism. Now see here, you can see here this is one link which is a fixed link. Suppose this link was not fixed and only 4 links were there. Which are the 4 one? This is a crank, this is a connecting rod, this is the piston, and this I can consider as the cylinder link. If I am not fixing the cylinder, I will call it as a kinematic chain. But once I fix one link, that chain will be called as a mechanism, because now it is able to transform the motion. Now it is able to transmit the motion. So the motion transforming device is called as mechanism. Same way you can see here. Suppose I have not fixed this link frame, then this would be called as a kinematic chain. But once I'll make this link as a fixed link, you know, the crank will start rotating, the connecting rod will start oscillating, and our rocker or lever will also start rotating and motion will be transformed. So this will be called mechanism when a fixed link, frame link will be fixed over there. Let us move further to our another example of a machine. Now, mechanism is only able to transmit motion. But once the mechanism starts transmitting power, it will be called as a machine, right? So it's written a machine is a collection of mechanism. In a machine, you won't find only one mechanism. Sometimes more mechanisms would be there inside a machine, and when it will start transmitting the power, you can call it as a machine. The simple example for all mechanical engineers is a lathe machine. You can know that lathe machine is made up of several mechanisms, and when those mechanisms will transmit the power and motion, it will be called as a machine. So machine not only transmits motion, but it transmits power also. Mechanism only transmits motion, but machine transmits motion as well as power. Moving further, I'll like to give you an example of difference between a mechanism and a machine. You can see this is a drafter, a mechanical drafter. Mechanical drafter will only be able to transmit motion. It won't be able to transmit power. But if I will put some gear mechanism inside several other mechanisms, then they would be able to transmit on not only motion, but they will also transmit power. So there is one very famous statement in kinematics. It says that though all machines are mechanisms, but all mechanisms are not machine. This is a machine. It is also a mechanism because it is going to transmit motion as well as power. But this is a mechanism, it is not a machine because it won't be able to transmit power. It will only be able to transmit motion. So moving further, in short, I would like to put this into a nutshell where we started from. We started from link. Link is just a single resistant body, a single machine element. When two links are connected such a way that they have relative motion, it will be called as a pair. When the pairs will be connected in such a way that they have a constrained motion, it will be called as a chain. When one link in the chain is fixed, it will be called as mechanism. Mechanism only transmits motion, but when the mechanism will start transmitting power, it will be called as a machine. So kinematics is nothing but study of links, pairs, chains, mechanisms and machines. So thank you for listening. I hope it was happy hearing for you, and this would have been a very good content for all of you. Thank you so much.